So next we have these capacitors. It says 104 picofarad. That's not quite right, but it does have the 104 listed on it. So at least it does line up with that. And so we have on the silk screen, we've got 104 written. Let's see if we can do a few of these at once. So there we go. Actually, I'll just change that one round so it's facing the same way as the others. It doesn't actually make any difference, but it does make it look better if everything is facing the same direction. Now, what you can do, because these are all roughly the same height and they're all taller than every other component, if you're careful and quick, you can just flip this over onto its back and it will hold it roughly in place, and we can do our little trick of just soldering up one lead on each of these capacitors, and then we can check to see. We can see they're not too bad. Just straighten a couple of them up. We can go in, I shall turn it around again so it makes it easier, and then just solder the remaining leads. There we go. Starting to look more like a circuit board now. Now we've got our little transistors. Now these just need the leads splaying ever so slightly to help them get into the holes in the circuit board. Not a lot. They will splay out a little bit more as you insert them. There's one up here, and you can see the shape. There's a flat here, and then sort of they've got it angled. That's to match up with the flat being where my thumb is, and the rounded part being where my finger is. You get these in the wrong way around, it won't work, and of course it may be damaged. So we can put those in and just don't try and push it all the way down to the surface of the circuit board, but leave a little bit of a gap. It helps to dissipate heat, and also it doesn't put strain on the actual package itself. So here we've got the other one. Again, they're marked as 8050, which is what we saw was on the package itself. As you can see, if I hold it this way up, as you put it in, it splays the leads out a bit. So you can see if we push that all the way home, it would probably crack this package. But the good thing is that these will hold themselves in position because they've been forced to splay out. But we will do the same thing again. We will just solder up one lead, and we shall then check. These are a little bit more sensitive to overheating, so it's good to do this after you've practiced doing a few other joints. See, that didn't take for the first time. So we can just double check that these are even. It's just an aesthetic quality. It doesn't affect the effectiveness of the component if they're not completely even, but it just makes them look a little bit nicer. So let's do another lead on that. I'm having problems. Clean my soldering iron tip. Just having difficulties getting the heat onto these pads. Perhaps one criticism of this kit, the solder pads could be a little bit bigger. It's just making it a little tricky just to get the heat into the pad. As you can see, I'm swapping backwards and forwards with these. I don't want to soak too much heat into one component, but if you can let them cool off a little bit in between, then it just means that you're minimizing the heat going in. And this circuit board just wants to dance around. I'll just lean some cutters on it there, which might just help. No, not helping at all. Made it worse, actually. So that was fun. But anyway, that's those in, thankfully, in and on the right way around. What does it say next in the instructions? Next thing it says is the power socket. There's the power socket. And then it says to fix it with a pin of a part. So one of the offcut leads, we basically solder in above it, just to provide a bit of mechanical strength. So this is where the power connector goes. There's two little pins, plastic pins underneath that also fit into the circuit board. It's got two holes for it. So just try and make sure that those are all lined up. Those plastic pins have fit into the board. They don't protrude, but they just fit in. And I'm just using the actual case as like a form for bending. Now I'm heart scared of letting it go in case those drop out. So what I'm doing is I'm just bending the little tiny tangs. There's not much of them there, but hopefully that's enough to hold it in place while we solder it. Now the reason I wanted to solder those in first before I soldered these pins in is it's always good practice to solder the mechanical strengthening aids or pins of a connector, even though this one isn't actually physically molded into the connector. But it's good practice. Do the mechanical mounting solder points first, and then the actual electrical contacts can be made and soldered so that they are not under any additional strain. Next up, the installation of the 2.2 microfarad capacitors. It must be these ones. There's two different values of electrolytic. So these also are polarized or have a positive and a negative. Now on the body of the capacitor we have a stripe, and it's actually got a legend of a minus or a negative symbol. Of course, on the instructions it mentions that as well. But helpfully, usually on electrolytic capacitors, the long lead is the positive. So if we come here, we have a 2.2 microfarad capacitor. One side has been shaded with a stripe, so we know that the stripe goes to that. But also we've got a positive symbol there, so we know that the long lead goes into this square hole. And again, that usually is a standard square pad, indicates a positive. So again, we put them through and then we can just gently spread these leads ever so slightly, which will hold that in place while we get our other one, which is down here. So again, we've got our square pad and we've got our stripe on the board and corresponding to the stripe on the capacitor. Again, just take a look to see if we need to adjust these. They seem to be sitting okay. And that's those in place. And that's our first sheet of instructions done.